In this video, we're going to start looking at a couple more functions, the remove function and the empty function. Okay, so the empty function of a linked list is the simplest one. And it's remarkably similar to checking if the array list was empty. All we need to know is the head null? Is it null pointer? Because if we've made an object and there's nothing in it, then the head and tail should both be pointing to nothing. They should have the value of null. And so all we need to do in our function to check if the list is empty is return whether or not head is equal to null pointer. And if it is equal to null pointer, it is empty. And if it's not equal, then there must be something in the list, right? So whether it's one thing in the list or 5 things in the list, we don't know. We just know that there is something in the list. And so in the case on the left, we would return true that it's empty. In the case on the right, we would return false that it's not empty. Okay, so we need empty for remove. Empty will help us just a little bit in the remove function. So with remove, we're only removing the first item in the list. So what we have to do there, head will always be pointing at the first item in the list. And so we need to redirect head around that item and then delete it so that it's no longer occupying memory. And of course, there is a concern. What if you tried to delete something from an empty list? Well, you could allow that to raise an error, and then the programmer should fix their code, because really, a programmer doing a good job should never try to remove something from an empty list. Or you could just handle it defensively and check to make sure the list is empty before taking an action. So there's kind of an implementation choice there. And what we'll do is be a little defensive. So our remove function takes an item as an argument and is going to return a bool. And so the item is where we're going to store a copy of whatever we remove. And I pass it in by reference so that whatever we copy into that variable can be seen in the caller when we're done. This isn't going to reference the object we're removing. It's just going to hold a copy of the object we're removing. The reference is for the sake of whoever calls this function being able to see what we pass back. Right, and then the return value is a Boolean that tells us, are we passing anything back? Did we actually remove anything? We're going to return true if we remove something and false if we don't. So the outer check we do here in this function is just to see if the list is empty. And if it's empty, we're going to skip this whole if block and just immediately return false, saying there's nothing in the list, there was nothing to remove. So don't look at the copy variable because there's nothing in it that you should care about. Okay, but if the list is not empty, then we need to take some action. And so the first couple of things I'll point your attention to is the fact that we have this variable called copy and temp. And so copy, we're going to get the item out of the head and store it in copy. This will in fact invoke a copy constructor to make sure that whatever's inside head, whatever's in this item object gets copied into this item we're passing in. I'm sorry, not the copy constructor, the assignment operator to copy everything over. And then temp, we're going to set up the thing that we're going to temp is whatever comes after head. So in this case, the head is milk, and we're going to remove milk. And since our list isn't empty, we know there has to be at least one item in the list, and therefore head next could be null. This could actually be nothing. We could have one item in the list, or we could have multiple items in the list. And so temp is pointing at whatever comes after milk here. And if temp happened to be null, then we would need to be careful that we never try to dereference temp or use the arrow operator on temp, because that could lead us to problems. So you're going to notice that we never do that, because that could be wrong. But we do need to know what's there, right? So we have this copy now, and we have temp pointing at whatever comes after milk. Okay, and having done that, now we can delete head because we don't need head anymore. We've made a copy of it, and we have a pointer to what comes after the current head. So we delete head, and that's why I drew this X over milk, because after we call delete, we should never try to access that object again. And then we overwrite head with temp. And so now this head pointer is going to point around milk, going all the way to this node here. Now, if temp had been null, if there was no eggs and milk was the only thing in the list, then we would have set temp equal to null, because next would have been null. And then when we set head equal to temp here, we would be setting head equal to null. And so then there would be nothing in our list. There's one other trick we need to do. If it turns out that temp was in fact null, then that means our list is empty. And so if temp is the null pointer, then head is going to be the null pointer, and tail must also now be the null pointer, because head and tail, if there's nothing in the list, they should both be null. If there's one thing in the list, they should both point to that one thing. And then once there's more than one thing in the list, head and tail will point at different nodes, head at the first node, tail at the last node. And so if temp is equal to null pointer, it means that there was only one thing in the list. We just removed it. And so now tail should also reflect the fact that there's nothing in the list. We set it to null pointer. Okay, and after we do that, our list, is going, for this case, head will be pointing at eggs, tail will be pointing at eggs. In fact, tail doesn't change for this list because since temp is not null pointer, temp is actually pointing to something, then we won't take this code and we won't modify tail. Okay, and then we return true to reflect the fact that, okay, we really did remove something from our list, and the item that we passed by reference in here will have a copy of what we removed. It'll have a copy of milk. And since we're returning true, the caller can then use that information in some way. Okay, this remove code, it's only removing from the head, and it will work whether there's nothing in the list, right? Because we check to make sure it's empty first. It'll work if there's one thing in the list. We talked about this. We're dealing with the possibility that we set head to be null pointer, and therefore we update tail to be null pointer. So it works for one case, and then it works for any arbitrary size list after that, reflected by 2 items or more, right? We looked at it for 2 items, it works. And if it's more than 2 items, it's also going to work, because these operations are basically all the same in that case. All right. So that's remove, and that's how remove works.